Hello and Assalamualaikum. My name is Muhammad Shukri and I will talk about plastics shaping process. Plastics shaping process has been used widely in manufacturing. This is because of the unlimited variety of part geometries that can be produced using this process. Furthermore, this process produces net shape, so it requires no machining or any other process to get our desired geometry. Furthermore, it requires less energy and operate at lower temperature. And finally, it requires no finishings such as painting and coating. There are several types of plastics products. Some of it is molded parts, extruded sections, films, sheets, insulation coatings on electrical wires, and fiber for textiles. In addition, plastics are often the principal ingredients in other materials such as paints and varnishes, adhesives, and various polymer matrix components. There are two types of plastics, thermoplastics and thermosets. Characteristics of thermoplastics are it softens when heated, completely reversible so that it can be remolded and recycled. The advantages are thermoplastic is highly recyclable, high impact resistance, chemical resistance, and eco-friendly manufacturing. The disadvantages are generally more expensive than thermosets and can be melted if heated, so it is not suitable to use in appliances that generate heat. The characteristics of thermosets: it disintegrates when heated, irreversible, so it cannot be remolded and recycled. However, it eliminates the risk of melting. So the advantages are thermosets are more resistant to high temperature than thermoplastics. It is highly flexible design and high level of dimensional stability. The disadvantages are cannot be recycled, more difficult to surface finish, and cannot be remolded or reshaped. There are two main properties of polymer melts: viscosity and viscoelasticity. Viscosity is the ability of the fluid to flow. The higher the viscosity, the slower the fluid can flow. And viscoelasticity is the tendency of the fluid to return to its original position. And the next properties of polymer melts is mole flow index, a measure of flow and viscosity depending on temperature and shear rate. Plastics extrusion, compression process in which material is forced to flow through a die orifice to provide long continuous product whose cross-sectional shape is determined by the shape of the orifice or die. Plastics extrusion is widely used for thermoplastics and elastomer to mass-produced items such as tubing, pipes, holes, structural shapes, sheet and films, continuous filaments, and coated electrical wire. It carried out as a continuous process. Extruded is then cut into desired lengths. Extruders can be divided into three main sections to serve several functions. The first is feed section, where the feedstock is moved from hopper and preheated. The second section is compression section, where polymer is transformed into fluid. Air mixed with pellets is extracted from melt and material is compressed. The last section is metering section, where melt is homogenized and sufficient pressure developed to pump it through die opening. This is injection molding machine. Injection molding is basically almost similar to the plastic extrusion. The only difference is the extruded goes into a mold. So this injection molding consists of injection part and clamping part. Plastic molding machine working principle. First, the autoloader plastic material into the barrel, which is surrounded by heating element and melting the plastic. In the barrel, which assembled with servo motor screw, the plastic melt will flow up the screw and under the heating condition get tight and move forward to the screw head. At the same time, due to the plastic reacting force, the screw will step back. So at the screw head, it formed a plastic melt saving space to finish its plasticizing process. At the same time, under the injection hydraulic cylinder force, the screw will injection the plasticizing melt into plastic mold through the nozzle. The plastic melt will remain in the mold cavity through the holding pressure, cooling process, and then form into solid shape, ejected out of the mold. So the plastic molding machine main recycle process is including quantitative feeding, plasticizing, injection molding, the shape pick up the piece, then close the mold to the second recycle process. This is the figure of compression molding and transfer molding. Injection blow molding has three types: preform injection, blow molding, and ejection. It has three processes, which is preform injection, blow molding, and ejection. Extrusion blow molding. In extrusion blow molding, a hot tube of plastic material is dropped from an extruder and captured in a water-cooled mold. Once the mold is closed, air is injected through the top of the container. When the hot plastic blows up and the mold material freezes, it's able to maintain its shape. Shrinkage. Shrinkage is the reduction in linear size during cooling from molding to room temperature. Polymers have high thermal expansion coefficients, so significant shrinkage occurs during solidification and cooling in mold. The typical shrinking values for polymers is as below. For nylon 66, the shrinkage value is 0.020 millimeter per millimeter, polyethylene 0.025, polystyrene 0.004, and PVC 0.005. There are several factors that affect the shrinkage. First, fillers in plastics tend to reduce shrinkage. The second one, injection pressure. The higher the pressure force, more material into more cavity to reduce shrinkage. The third factor is compaction time. Similar effect, long time forces more material into cavity to reduce shrinkage. And lastly, molding temperature. The higher temperature, lower polymer melts viscosity, allowing more material to be packed into mold to reduce shrinkage. That is all from me. Thank you.
Okay, I will start with thermoforming. Thermoforming is a process that a flat thermoplastic is heat and deformed into a desirable shape. Only thermoplastic can be deformed. Extrude sheet of thermosetting or elastomer polymer have already been cross-linked and cannot be softened by reheat. We often use like polystyrene, polyethylene, and polypropylene for thermoforming process. Next, about sheet and film production processes. Most widely used processes are continuous and high production operation. This process include slide die extrusion of sheet and film, blown film extrusion process, and calendering. Okay, for slide die extrusion of sheet and film. Production of sheet and film by conventional extrusion using a narrow slit as the die opening. A slit may be up to 3 meter wide and as narrow as 0.4 millimeter. A problem is uniformity of thickness throughout the width of the stock due to drastic shape change of polymer melt as it flows through die. Edge of film usually must be trimmed because of thickening at edge. This is the photo about the process, slit die extrusion. They have section A and section B. Okay, next is about blown film extrusion process. It is a combined extrusion and blowing to produce a tube of thin film. This is a process sequence. First, extrusion of the tube, and then the tube is drawn upward while still molten and simultaneously expanded by air inflated in it through die. The air is blown into the tube to maintain uniform film thickness and tube diameter. This is the figure about the process. We can see all the process start from extruder, have bubble, nip roll, have a head source, oven, winder. Okay, next about calendering. Calendering is a stock is passed through a series of gap decreasing size by made by a stand of rotating roll while final roll gap determines sheet of thickness. We have the feedstock rolling by the roller until we have a sheet stock. This is a coating impregnating fabric with rubber used in producing automobile tire, conveyor belt, inflatable raft, and waterproof cloth, tent, and raincoat. Okay, we can see the process. This is about rolling, and then we coat the fabric. Next is about roller die process. It is a combination of extrusion and calendering for better quality product. We put the material into the barrel and then we roll it using the roller, and then we get the product. And next, we have a spinning process. Spinning is a manufacturing process for creating polymer fiber. It is a specialized form of extrusion that uses a spinneret to form multiple continuous filament. There are many types of spinning. First is melt spinning, second is dry spinning, and third is wet spinning. Okay, for the melt spinning. Melt spinning is the simplified explanation of melt spinning is that the polymer granules are melt and then extrude through the spin head. The metering pump controls the flow of the molten liquid to the spin head, where it is filtered before the extrusion to ensure any unmelt are removed so that they do not form part of fiber which will cause weak point. The quench air cools the fiber are they emerge. In order to the spin cool filament fiber, a lubricant must be applied as the synthetic fiber are not conductive and therefore static can be problematic. The winding speed is critical element to the alignment of the polymer in the fiber which is influence the strength of the resultant fiber. Okay, this is the figure about melt spinning. We can see all the process start from polymer pellet until the winder. Okay, next is dry spinning. Dry spinning is to melt a spinning but starting polymer is in solution and solvent can be spread by evaporation. A step is extrusion through the spinneret, then extruded is pulled through a heat chamber which is remove the solvent, leaving the polymer used for filament for cellulose, acetate, and acrylic. Okay, next is wet spinning. Wet spinning is it is similar to the melt spinning, but polymer is again in solution. Only solvent is non-volatile. To spread polymer, extruded is passed through a liquid chemical that congratulates or precipitates the polymer into a coherent strand which are collected onto bobbins used to produce filament of rayon, regenerate cellulose. Okay, next process is the mold. The special tool in injection molding. The custom design and fabricate of the part to be produced. When production is finished, the mold is replaced with a new mold for the next part. Various types of the mold for injection molding. 2-plate mold, 3-plate mold, and hot runner mold. Okay, this is figure for 2-plate mold. For 2-plate mold, we have a stationary slide and the moving slide. Then we have a 3-plate mold. 3-plate mold, we have 3 part of the plate. We have stationary platen, movable platen, and stationary mold plate. Oh, sorry, intermediate mold plate. And next we have hot runner mold. This is a figure about hot runner mold. This is the air gaps, manifold, and cavity. Next, I will talk about product design guideline generals. Plastic are used in variety of diverse demanding application. They are design elements that are common to most plastic part. First, thickness, then the ribs, bosses, gussets, and draft. This is the product design guideline for extrusion. First is we have the wall thickness. For the wall thickness, when deciding how the thickness of the wall profile should be, strength, optimum, cost efficiency of the main consideration. And then that we have uniform wall thickness, exception. It is cost perfectly acceptable for the profile to have wall different thickness. For example, for the strength reason, it may be best to concentrate on the weight or the thickness away from the center of the gravity. Then we have the soft line, solid profile if possible, fewer cavities in the hollow, and then profile with deep channel. For profile for deep channel, it is with pocket or channel. There is a basic that width to the height ratio should be approximately 1:3. This ensures that the strength of die do not jeopardize. Then the next guideline is head sink. Lastly, the decorate. Decoration has several advantages. The first, design. The second, masking for imperfection. Third, imperfection against the damage during handling and machining. Okay, next, the guideline for molding. First, the wall thickness. Cost saving are highest at the highest point when the component have the minimum wall thickness, as long as that thickness is consistent with part function and meet all molding filling consideration. Okay, the next guideline is void and shrinkage. Troublesome shrinkage problem can be caused by the intersection of the wall that are not uniform in wall thickness. For example, might include ribs, bosses, or any other projection of the nominal wall. Since thicker walls solidify, since thicker walls solidify, the area they are attached of the nominal wall will shrink as the projection shrink. Next guideline is rib intersection. Because of the thickness of the material will be greater at the rib intersection, coring or another mean of material removal should be employed to avoid excessive sinking from occurring at the opposite side. Next is the sharp corner. Sharp corner greatly increase stress concentration, which when high enough can lead into the part of failure. Sharp corner of Okay, that's all my part about plastic shaping process. Thank you.